Welcome all to Vectors Class 8, and this will discuss about components of a vector. Components of a vector means nothing but the parts of a vector. So if I am writing that A vector is equal to nothing but C vector plus D vector, so we can say that the C vector and D vector are the parts or component of A vector. Or if I am representing it something like this is C vector, and let's say this is our D vector. And if I am adding the C vector and D vector, I am getting the resultant as nothing but, let's say, A vector. So we can say that this C vector and D vector are the components or the parts of A vector. It doesn't mean that a vector can have only two components. A vector can have more than two components. That means if I am writing this A vector is equal to, let's say, B vector plus C vector plus D vector plus E vector. So we can say that this B vector, C vector, D vector and E vector are the components or the parts of A vector. So we can represent it something like this. Assume that this is our B vector, this is C vector, this is D vector, and let's say this is our E vector. And if you are adding this B vector, C vector, D vector and E vector, we are getting the resultant vector as nothing but, let's say, A vector. So we can write over here B vector, C vector, D vector and E vector are the parts or the components of A vector. And one thing you can observe that it's not like a scalar addition. So the magnitude of A vector can be more than that of its components, or it can be less than its components, or it can be equal to its components. So you can write down the notes. A vector can have more than two components, and the magnitude of resultant vector can be greater than, less than, or equal to its components. Now discuss about rectangular components of a vector. Rectangular components of a vector means, assume that we are having a vector, take it as A vector, and the two components of this vectors are, let's say, one component is nothing but B vector and another component is nothing but C vector. Over here, the C vector and B vector are perpendicular, then this B vector and C vector are said to be nothing but rectangular components of A vector. So one thing we can write, this A vector is equal to nothing but B vector plus C vector, and so we can say that this B vector and C vector are the components or the parts of A vector. And over here B and C are perpendicular to each other, then B vector and C vector are said to be nothing but rectangular components. You can write the notes. When there are two components of a vector and if they are perpendicular to each other, then they are called rectangular components. Now discuss how to find out the rectangular components of a vector, or how to resolve a vector into two perpendicular components. So over here, let's say we are having a vector C vector, and according to the diagram, we can say that this B vector and A vector are the components of this C vector. And let's say the C vector is making an angle theta with respect to the horizontal or with respect to this B. Then we can resolve or split C into two components. So we can find out what about the value of this B. So if I am just writing the equation for cos theta, so cos theta is nothing but, we know that adjacent side, that is B, divided by hypotenuse, that is C. So we can write the value of B will be equal to nothing but C cos theta. Now same as like that, if I am writing the value of sin theta is opposite side divided by hypotenuse. So you can write the value of this A is equal to nothing but C sin theta. So we can say that this vector C vector can be resolved into two vectors of magnitude C cos theta and C sin theta, or we can say that C cos theta and C sin theta are the rectangular components of B vector. Or we can write it in other sense, like suppose if you are having a vector, take it as C vector, and our aim is to find out its components or its rectangular components. So we can resolve the C vector into two components. If you know the value of angle, let's say theta with respect to this horizontal, so we can find out the component of C vector along the horizontal direction, that is equal to nothing but C cos theta. So always nearer to this cos theta we'll get cos theta, and opposite to this angle we'll get a c sin theta. Or the same vector we can represent it something like this also, like this component, if we can say that this is also equal to nothing but c sin theta, and this is equal to nothing but c cos theta, because you can observe that this vector and this vector are equal. So even we can write this component is also equal to nothing but c sin theta. We can take another example. Over here, this vector A can be resolved into two components. One is along x-axis, another one is along y-axis. We can resolve this one into two rectangular components. So if this angle is given as something but theta, so we can write component of A along this direction will be equal to A cos theta. Always adjacent side is A cos theta, and the other vector we can take it as something but A sin theta. So like this, any vectors we can resolve depends upon the angle into two perpendicular components. If I'm taking another example, let's say this B vector, and assume that this B vector is making an angle theta with respect to y-axis. So we can find out what about the component of this B vector along y-axis. That will be equal to nothing but B cos theta, and the component of B vector perpendicular to this, that we can take it as nothing but B sin theta. So we can resolve this B vector into two rectangular components. In different chapters we'll have application of this. So I'll take one more example. Let's say if you're having a vector, take it as B vector, and if this vector is making an angle theta with respect to this negative y-axis, so we can resolve this B vector into its components. Component of B along this direction will be equal to nothing but B cos theta, and this component we can take it as nothing but B sin theta. So always remember that near to this theta, this side always will take it as cos component, and the other side or opposite side will take it as something but a B sin theta. Hope so that you understood what about the component of a vector and the rectangular components of a vector. If you're having any doubt, or if you'd like to interact with me on live classes, or if you want to solve more questions to improve your performance, please let me know. Along with that, please don't forget to like this channel and subscribe this channel. Thank you.